Okay, while most of you guys were not here, we started talking about exceptional handling. So if you haven't got a chance, please try to catch up the lecture recorded on last Wednesday. So we talk about the concept of exceptional handling. So this is the basic syntax we went through. Essentially, it's a try and catch clause in pair. You might have a one try clause which followed by a bunch of catch for different type of exception. So essentially, what is an exception? Exception is a typed object that's produced in the middle of a block of code. And then it will release the control to the original block of code, and it basically jump out. So if you look at visually, looks like what the exceptional handling looks like, is that you have a bunch of code, and somewhere in the code, it might not be the top level code we're talking about. It might be one of the function, one of the library, or one of other thing which is included as part of the code, that anywhere in the deep, maybe 3 or 4 layer, there might be some kind of exceptional condition that trigger a code related to the throw statement. So the throw statement, so let me just show you this one. I mean, for example, this was similar to example I presented. You see that I have a try clause, and somewhere there is a throw, some kind of string. I mean, in this example, you can see I have a 2 catch clause. The first clause is catching an integer. And the second clause is capture a traditional C string, which is a character star. So you see that in the middle of the execution, I have this 2 type of throw statement. If you say throw null pointer, and that is essentially matching to the traditional C string, which is character star, so that one will trigger this particular catch clause. So essentially from that particular position, immediately jump to the red part of the catch clause. And then after you finish this part, it will start asking whatever remain in the code after the last curly bracket, the right curly bracket, and it will from here jump over here. Oh, I actually have the PowerPoint slides here already. It will do something like this. From that throw statement, immediately it will jump over here. It will finish whatever code inside the red part, and then it will go to the remaining clause. I mean, on the other hand, you potentially can also do it differently, which is this part, which you have another throw statement, which is the green part. It will be catch because you throw the code, throw a tag index, which is an integer, and therefore it will be catch by the green. And also with whatever, by the way, I should say that you can see each of the catch clause has a parameter, has an argument. And that argument is related to whatever type it is. So in the previous case, the string pointer is going to be null pointer in the red part because that parameter being shuffled in here. And over here, you can see that this integer n is matching to whatever tag index. Based on the logic, it's likely to be a negative integer. So that number will be passed into the catch. So essentially, the catch clause will have some knowledge about what is the information that's being included in that exception. So that's the idea of doing exceptional handling. So let me summarize: is you have a try clause, and inside there you use a throw statement, and your throw is going to throw an object. That object could be an integer in this example, or could be a string in this example, or it could be anything. Could be a C++ object that you can throw, and such that how do I match the catch is based on the function signature of the input argument. Whatever match, it will match that one, it will execute that one, and then after that, it's going to continue to executing the remaining code. Okay. All right. Any question about this particular diagram and the basic usage? Yes.
Example, if both object pointer was null and tag index is less than 0, would it jump to both of the catch?
It will not. It will depending on which throw statement will be executed first. You can see that there is a, so it's not magic, is okay. I should say that. The whole idea of exceptional handling is not monitor the data variable of all your conditions, but except it rely on your code to perform the check. So your code is sequentially going to execute, right? And whenever it hit a particular condition that is raised the exception, then it will have a statement called throw. So essentially, this exception must be triggered by the throw statement. And by the way, if you don't have the throw statement, no exception will be caught or will be generated. So yeah, all right. So that's why whichever comes first will trigger. Okay. Any other question? Okay. I also mentioned last time that if you have a throw statement in the middle somewhere, even that throw statement was there not by you, but by the code you try to include it in your executable. And if you don't have the corresponding catch statement to catch that, then you're going to generate a runtime error saying that there is an uncaught exception. So the moment you start to introduce the concept of exception, you must guarantee that within all your code, you have something to catch, because you're using somebody else's code. If somebody has a throw, then you need to be ready to provide the catch statement to catch everything essentially. So which means that we need to have a more of a generic type of exception, which means that I don't know what kind of exception you're going to throw. Are you going to throw an ecs36b exception, or are you going to throw a JSON RPC exception? I have no idea. But we can have a standard exception called std : exception, and all the exception object you want to have in your program should be a derived class from that std exception, such that I just need to say catch, and then over here I would say std : exception e, which means that if you throw a standard exception, good, I can catch it with this one. If you throw a ecs36b exception, or you throw a JSON RPC exception, because it's a derived class, I can still catch that. And maybe I don't have all the information to handle that exception because it's derived class. And of course, you can see that is including immediately concept like inheritance, virtual function. They're all included in this kind of exception mechanism, and such that at least you might not be able to handle it perfectly, but at least you won't have uncaught exception. So let me show you a example, which I already showed you last time. About this scenario. By the way, everything is within, I have a new directory called CPP 13, which is an exception. It has all the code that we have been using last Wednesday as well as today. Everything is here. So let's take a look at one of the example. Let me go back to this bad alloc. Is that right? Let me actually see my code. Oh, I'm in the wrong directory. That's why. I should come over here. Yes, it's a bad alloc. Okay, so let's take a look at this example again. That where I want to be? Okay, let's see. Okay, this is the example. You can see that I'm in my code, there's no throw statement. This is a try clause. Okay, if you look at the try clause, you see that I'm trying to allocate a large two-dimensional integer. Oh no, not two-dimensional. It's a single-dimensional long integer array. And the size of the array is controlled by a number called m size, which is I will enter as the input argument. So if you look at this piece of code, that this piece of code doesn't have any throw statement. So the throw statement will be will be generated within the execution of this code. And now you see that the way I catch it is just catch std exception reference E. All right, so I basically receive a object that's the type of std exception or is derived class. Okay, if you see the reference, why I put reference here? Because I'm not doing call by copy. I'm doing call by reference. So I will be able to see the original everything, the derived object. If I have any virtual function, I'll be able to perform on this E. All right, so let me first try to do this. Let me change this to be, let me just get rid of this line. Let me just get rid of this line first. There gotta be a better way for me to do this here. So I have a try, but I didn't have any catch. Let me see, does this even compile? That alloc.cpp. Okay, so it has to have a catch. I cannot just get rid of the catch, but now I'm doing this catch. I would say integer and. Okay, I would just, oh, sorry, mistake. I just catch an integer, not the std. So just do nothing here. That should works fine for this. Okay, so I'm going to do this /a.out 111. Okay, if I do this, it basically just allocates some memory. There is no exception. You can see that I put the dimension of the long integer array I wanted to allocate. So I'm going to make it this really big. Okay, now you see that I try to allocate a huge array, and the system realized the size is really too much they can handle. So it basically trigger generating a exceptional condition called bad allocation. So this is very useful when you do malloc, when you want to create a lot of stuff. If you're running out of the memory, that the system is going to generate a exception saying that, wait a minute, you try to do something which is more than I can handle. So it will be an error condition. And that particular error condition is called std bad alloc. That, by the way, there is a bunch of standard exception condition it will generate. Okay, however, you can see that the error message you basically receive is saying that uncaught exception, because I kind of commented out about capture the std exception, and therefore I tried to catch an integer, but the integer doesn't match with the exceptional object. So therefore I'm going to see the uncaught over here. So let's try to change this a little bit. So if I change this back, Just unblock this. So I recompile and then rerun this code. So now you can see this time, I'm still getting the same exceptional condition, STD alloc, but this one was caught properly. That's actually executing. If you look at the code, what I did is I come into here. This is the E, which is the object. That's the related to whatever exception is generated. By the way, this is generated by one of this new command. Inside this new is just like a malloc. By the way, why is new? New is malloc plus initialize the object. Okay, if you know C is malloc, but if you know C++ is where you're using new. So within the new, there's some part in the new, it will throw the STD bat alloc, which is a standard exception. And so take a look at here, that it basically tell you that what is the message you can print, that under that object E, there is a virtual function called what. Basically say what's the error message. And also you can look at the type name, type ID, which is try to find out what is the class name for that particular exception. It's, by the way, type ID is a function for you to retrieve the information about the class name of that particular object. So one thing I should take a look. And remember, this function is called std9 bad alloc. So means that std bad alloc is a derived class from std exception. And that's the class name for that. It's not exactly the class name. The class name should be just bad alloc. The type ID includes some kind of prefix related to that. So I want to show you this slide that's basically tell you that all the STD. So here is all the STD that you can have. Okay, this is the prototype for class STD exception. You can see that it has a virtual function called what we just used. And then you define a bunch of derived class. This is also the standard STD derived class, such as bat allocation. That was the one that we just showed you. And then there's a bat casting, bat type ID, bat exception, logic failure, and a bunch of other things. So that's the all kind of possible exception, standard exception that can be generated from the system. And also, you will see later that we define other exception that's inheriting from the STD exception, for example, like a JSON RPC exception or the ecs36b exception. They all a derived class from that as well. Okay, let me show you the second example, which is 2. So let's take a look at this. Now I include the ecs36b exception .h. So just let me show you what is this code. So you should have it already. Exception. So you can see that this is an exception, and then I have something which is I want to show you a bit of a trick about multiple inheritance. So I define a kind of dummy class. I just want to show the impact about multiple inheritance. So I have a class called ecs36b special. It's just an integer. It's nothing really special. Okay. And what I did here is that I have this ecs36b exception. It's multiple inheritance. The first element is STD exception. The second element is ecs36b special. So I have a multiple inheritance. And the reason I want to inherit from STD exception is that, well, if I have a code which has a STD exception catch clause, such that when you generate ecs36b exception, I'm counting on that clause to catch this. Okay, and I probably should show you this later, but I'm telling you there are 8 different ways you can do multiple inheritance within this 2 class. One is do public STD exception, ecs36b special, and you can see that I kind of twist the order, I adding public or not, and public virtual or not, and I'm adding all this. The first 4 ways I listed there, they're all okay. They're all be able to accomplish whatever I want to accomplish. So you should try this yourself in this code, BetAdlock test 2, to see that all these cases, how exception might interfere with the multiple inheritance in this case. But if you do this 4-way, it won't work. If you do any of this 4, it won't work. If you do switch order and didn't put a public in front of exception, the important thing is you need to have a public in front of the STD exception. Okay, if you don't do that, then this one will not behave as you expected at runtime. Okay, if you take a look at the first 4 cases, right before STD colon exception, you have a public as the keyword you listed there. Okay, so that's the definition of this exception. So it's a derived class, multiple inheritance from the STD exception. And it has nothing magic yet. I just basically create 2 different constructor. One of them, I actually include a JSON as an argument because I want to be able to handle some of the case I'm going to show you. That's the only thing. Okay, so let's take a look at what is Now let's take a look at this piece of code. So this piece of code is almost identical to the previous one, but except I adding this statement here, ecs36b exception. I basically throw a ecs36b exception in between those 2 malloc statements. Okay, I'm doing that in between that. So over here, you can see that I have 2 catch clause. The first catch clause is specifically try to catch for ecs36b exception. The second one is try to catch for the standard exception. By the way, not only I catch 2 different kind of exception, but also they are derived from each other. Okay, STD exception is the parent, and ecs36b exception is the derived. Okay, with multiple inheritance. All right, so let's try to run this program as it is to see what happens. Okay, what's happening? Okay, I know because will this work? Minus L. Okay, I'm going to borrow a line from the makefile. I forgot to do one thing. Okay, I'm going to do this, borrow this line. I should just do JSON CPP. This should fine. Still not working? That's interesting. Anyway, I'm going to do this. Okay, so I have to borrow the whole line from my makefile. Sorry about that. And then this will link to the JSON part. Okay, so now I'm going to run a.out. If I run a.out, nothing happened. Okay, oh, because I forgot to put the argument. Okay, so when I enter a really small number, and essentially it will throw the ecs36b exception. As you can see that we have look at this code. Look at this code, because this one is a a moderate size array. So that's why the memory has no problem to handle that. So I'm going to throw a ecs36b exception, and this will trigger this part. So that's why it says inside ecs36b exception. And then what is the exception? It will print it, say ecs36b, and then look at here. I'm actually print the type name, which is the class name. And take a look, what is a class name? The class name is 16, and then ecs36b exception. So it's essentially have some kind of prefix and then has the rest of the class name. Okay, that's what type IDs. By the way, to use type ID usually give you some good information, but to get the true class name of the original one, you need to do more twists, and sometimes it might not be expected because sometimes the prefix has two characters, sometimes has 3 characters or more. So that's why we're not sure how to use that, but this is definitely a debugging information for you to see that. Okay. All right, so let me try to do this. If I get rid of this, if I get rid of this part, I only have a standard exception. And now let me try to run the code again. So you see, I get rid of ecs36b exception. Now is go to the standard exception. Okay, and then if you look at the, wait a minute, it still go for, oh, because what? Because it's actually inside the standard exception, but what? And the type ID is a virtual function. And therefore it's still trying to catch the original one. Okay, information for what? Because it's a virtual function. But the thing is that the important thing to show is that I will be able to catch, even if you have a derived exception, I can still use a standard exception to catch that. Okay. Now let me try to get this back. Okay, now we try to do it somewhat differently. If I do, let me recompile this again. If I do this, like what I did before, a huge array, now you can see that I'm actually causing the standard exception, and then it will say that the standard exception is std.alloc, which is the memory allocation error. Okay, so this two-file, the bet-alloc test basically tell you how you can control the exception and how you should set up your catch clause to catch different kind of exception, depending on the situation you want to deal with. Okay, any question? All right, so let me see. Do I have everything I want to talk about here? Okay, good. All right, so now I'm going to use a more complicated example. I call it, this is a remote exception handling. Remote exceptional handling. So let me first get rid of the let me get rid of the log. Yeah, log I can keep it there, but I want to get rid of the object. I want to remove all the object. So I'm going to show you my JSON RPC spec. So the JSON RPC spec is under this mobility JSON. Okay, so let me first take a look at more. You see a 36b mobility.json. Okay, so I defined 2 functions. One function is sending a message. So this is almost like an email program. By the way, you can write the email client, email server yourself by JSON RPC. If you think about that, it's just a sender and a receiver concept over there. So the sending program essentially say you need to define what's the name of the function is a send, and you provide the class ID and the object ID, and you have a JSON object which represent the content that you try to send as a message, which we will show you. And the second function we define is dump to JSON, which is basically say, hey, I want to go to retrieve that particular email message. that's actually sent to my inbox. Okay, so that is essentially the two functions. One is called send, one is called dump to JSON. Okay, so let me first talk about what is the program looks like. Mobility send.cpp. Okay, so this program is the send program. The first few lines is just like what you did with JSON RPC before, except now I'm really using this function ecs36b exception. I use this as example. So let me tell you that what is the message I'm sending. So essentially what I'm sending is that I have let me see, what did I do here? Okay, the message is sending from a particular team of student, a team of student as a standard that they want to send to their instructor. So I have two students, one is Tom, one is Jerry. You can see that I create three SP person object. One is instructor, one is student. And I essentially also have another object, another class called team. And within this team, I add a team name, which is the midterm 5. And then I have the student, the object over here to include it. So essentially is a team. Okay, let me actually tell you what is the class. You should take a look at here. This is also inheritance over here. I have a class called team.h. So what is a team.h? Let's take a look. So team.h is inheriting from commutable, inheriting from a class called commutable. And within the team, you have a name and you have a vector of SP person. So essentially, usually in the email program, the standard is typically one particular person. But over here, we kind of generalize this concept. So we allow the sender to be multiple person. I mean, for example, when you have a team project that you all want to submit, and usually you only have one student submit. And typically the instructor get it, and then the student unintentionally forgot to include all the team member, and such that only one of you or two of you got a credit, but the rest will get 0 at the end. So we feel that, well, why can't we have a email protocol such that you have a multiple sender instead of single sender? I mean, today's email is single sender, multiple receiver. Well, why can't we have multiple sender and multiple receiver? So this is the concept of having team and using commutable. So that's the definition of class team. So let me show you what is the commutable. So commutable.h is just a class. It basically just has a function of dump to JSON and JSON to object. So nothing else. It's just nothing, but it's just like a parent class to allow everybody else to inherit from that. Okay. However, and why we need commutable, but let me show you another class called SP person. SP person, on the other hand, is a single person. It's also inheriting from commutable. So essentially, commutable is the base class for both SP person and the team. So you think about person is a single person, a team is a multiple person, but they can all be a class called commutable. We have this. And why is this important? So we'll look at the message. So what is a message.h? So message.h is essentially try to say, well, how can one person send to the other? And you can see that the definition of a message is from a commutable to a commutable, where a commutable could be either a person or a team. So therefore, by having this inheritance hierarchy between commutable, person, and the team, and also has the message defined as commutable, we will be able to support any kind of number of sender, any kind of receiver. through this way. Okay, so that's how the message was defined. So that's the okay. So now we're going to try to go back to see this program. So we have a 3-person, and the team is basically the 2 students, Tom and Jerry. And then you have a message from Tom and Jerry to the instructor. And then within the message is essentially saying that, okay, this is related to midterm number 5 on December 8th of 2023. And the body is basically they want to, for example, they want to retrieve the ecs36b exception tutorial that's actually available for them to prepare. Okay, so that is essentially construct the message. So by this part, when I declare M content is equal to JV content, that means that now the M, the message M, has all the information, has all the sender, receiver, and also has the content, the header and the message being encoded over there. Okay, so now I'm actually going down here. So this part, you start to see JSON RPC stuff. We have the HTTP client, we have a my client, and then I start to use exception. I kind of try to put this part because I want to do this my client.send, which within that, I might trigger some exception, either related to JSON RPC or it's related to my own stuff. Okay, so I just basically call this function send over there. And by the way, I should change this to get rid of this first to message. The class name should be a message. Okay, and then there's a bunch of exception code, and then you can see I have 2 exceptional catch. One is catching ecs36b exception, and the other one is catching JSON RPC exception. I have a 2E, and then depending on the arrow is introduced by JSON RPC or is introduced by my message protocol. Okay, and it will call this way. Okay, so just take a look at this. Now I'm going to run the program and you will see what's going on. Okay, now I have all the program compiled. So I'm going to run the server first. So I'm running the server on the other terminal. And then I'm coming here. So first, I want to tell you that I do have, just like the last time I showed you in the persistent object, I have an object directory, which at this moment, there's nothing. Okay, you can think about the object is like your inbox. Okay, so every single message is going to introduce one extra file in your inbox directory. So I'm going to say mobility send. So when I do mobility send, there's no exception, okay? This is the message I produce. You can see that the content or the body and the header is related to midterm number 5, and the from is from this team and has a member, Tom and Jerry. Why is T-O-M-E? Did I make a spelling error? Let me just double check. I thought, I'm sorry. You see, I haven't watched the show for a while. Okay, sorry about that. Now I'm happy. Okay, by the way, now we look at the server. The server basically start to reserve an object called midterm5.json for whatever you want to have. And now we can see what's in the object directory. So if I go to the object directory, this is introduced by the server side. Now I create an object called midterm5.json. And let's take a look, midterm5.json. You can see that it has exactly the information you expect, right? Content, body, whatever over here, and then you have all the information related to a message using the JSON encoding. All right, so let's try to retrieve it. So the server is still there. The first thing I want to tell you is that, well, you can deposit a message to the inbox. You should be able to retrieve the message to see, what message do you have. So I can actually run now. I'm going to run the other program, which is, no, I have to go back. So if I do this, dump. Now I actually retrieve the object. I retrieve the message, content, whatever from, everything, okay? Status successful. I can retrieve the message and from the server. Okay, so you can see that I'm actually doing client server, but without any exception. Okay, let's try to do a few things. Now we can see the exception. So the first thing is I'm going to kill the server. You see I kill the server. So now I'm going to run the send again, or maybe I run the dump again. If I run dump, you can see that immediately there is an exception generated. This exception is generated. And this exception is, by the way, is RPC gen exception. And that exception is saying that, well, they try to connect to the server, but the server is not there. So there was an error. That's why there was producing exception -32003. Okay, that is a one type of exception. Okay, now I'm going to change this part a little bit. I'm going to run the server. Now I'm going back to the program, to the send. Instead, let me actually just change this a little bit. Oh, now I have a Tom and Jerry. I will say this midterm number 6. Okay. I call it midterm number 6. And no, we don't have midterm number 6. We only have midterm number 5. This is just for example. And what I will do, one thing I will do is when I call it, I'm not using message. I'm using, say, let me pick up a class. I will say thing. Okay, so thing will not be welcome by the server. The server expect I'm doing an email protocol, so I do not expect you send me something with a class thing. All right, so this is going to introduce a exception, but that exception is not produced by JSON RPC, but instead is by the server. Okay, so I'm going to Control X, Control C. I'm going to make again. All right, and my server is still running. What happened? Okay, my server is still running, so I'm going to run the send program. Okay, so now you can see that now I have the exception I received from the ecs36b. It says that the reason is the class thing unknown as the exception. So let me take a look at the code to make sure you understand how this is done over here. If you take a look at this piece of code, what I did is whenever I do a my client.send, if there is anything on the other hand at the server part says failed. Failed means that there was some exception being caught at the server side. So I'm going to encoding whatever reason I'm going to put in there. Okay, the first thing I'm going to check is whether the response from the JSON RPC from the server, which is a JSON, which is my V, whether this my V has status or not. If it doesn't have a status, that means the server does not even did his job in terms of producing the status such that we will know. So this part is that if the server does not even have that, so I would say the error message I produce here is RPC response without status. Okay, if you do have the status, then here I said if the status as string is equal to failed, which I know the encoding itself is a status, you can see what I did is I just throw ecs36b exception and then my V. And this will be catched by this one over here. Over here, this one, it will say, hey, wait a minute, it is a error message. And what was that error message? Is related to the whatever I just showed you. Yeah, the class thing is unknown, failed over here. Okay. All right, so I'm going to stop here, and if you have any question, I will handle that after the class. See you on Wednesday.